Question number 46. Question number 46, I think it is a little bit hard. It depends on your imagine. He said in the question, you have a pond and a boot. We will consider boot this container or this scoop. This container has a volume under the surface of water and a volume above the surface of water. The volume under the surface of water is empty. No water gets into this space before the leak. After the leak, the water starts to gets into the container and gets into and gets into. So the water which is here and here will get into the container, and the space will be full of water. This will make the surface of water goes down. I think it is clear in these two photos. The surface of water goes down from here to here because the water of the pond gets into the container and make the surface goes down. I hope you understand this. Question number 47. Question number 47 is a little bit different from the previous one. He said in the question that also a boot and a pond, but the container or the boot go deeper in the water. What will happen in this case? In this case, the container goes down and the water enters the container, and the space or the volume under the surface of water will be full of water. But when the container be full of water, it goes down. Much water, it goes down. Much water, it goes down. After this, you will find that the amount of water which will get into the container is equal to the space under the surface of water. This will happen, and this will continue until a quick action plugging the leak. We will find the surface of water doesn't change because the water which entered the container is equal to the space or the volume under the water, so the surface doesn't change. In this question, the container doesn't go down, so the water or the space, let me say it in another way, the amount of water which will enter the container is more than the space under the surface, so the surface will goes down. But here, the amount of water which will gets into the container is equal to the space under the surface of water. I hope you understand this. So here the answer is A, the surface will stay the same. Question 48. Okay, let's start. Question 48. We all know the ratio between the density of the object and the density of the liquid is equal to x over h. He didn't give us the density of the object, he gave us the specific gravity, so it is easy to calculate the density from the specific gravity. The density is equal to the specific gravity, or let me write Sg times 1000, as the specific gravity is equal to the density of the object over 1000, which is the density of the water. Kilogram per meter Q. So this is the density of the object. So x over h is equal to 800 over 1000, which the liquid is the water, and we all know the density of the water, which is 1000. That means 0.8. That means 80% of the object will be under the surface of water. But he wanted to know the volume which will be above the surface of water. That means 100 minus 80% equal to 20%. I hope you understand this. Yes, question number 49. We will use this rule or the quantity equation. A1 V1 is equal to A2 V2. That means V2 simply equal to A1 over A2 times V1. A1 is equal to by R square by R power 2 over power 2. By and by cancel. We will find that V2 is equal to R power 2 over the another radius power 2. All of this times V1. I forgot to write it here. So this is simply V2 is equal to R1. R1 he give us in the question the diameters. The ratio between the square of the diameters is equal to the ratio between the square of the radius. So the square of the diameter is 1. 1 square 1 is 1, and 3 square is equal to 9 V2. So the answer will be D. I hope you understand. Question number 50. Yes. The rate of flow. He said in the question the rate of flow. He didn't mention. He mean the volume flow rate or the mass flow rate. How can we know from the unit? The unit here is meter cube per second. So he mean the volume flow rate. If the unit was kilogram per second, he mean the mass flow rate. Sorry. The volume is simply equal to the V, which is volume, over time. And we all know the volume is the area times the height over T. Sorry. The height, which here is the normal distance. The distance over the time is the velocity. So we can put the velocity instead of h over t. We have the volume flow rate. I need to write L. He wanted to know the speed. We have the volume flow rate. We have the radius, so we can calculate the area. And we wanted to know the speed. Let us start with calculating the area. Area is simply equal to pi r power 2 we can or we have to convert it from centimeter to meter, so we will consider the radius as 2 over 100 because the unit here is centimeter power 2. So the area will be 1.256 times 10 power negative 3 meter square. This is the area. Let us substitute in this rule the volume flow rate he gave in the question, 0.008 is equal to the area which we just calculate, 1.256 times 10 power negative 3 times the velocity. So simply the velocity will be 6.4. After solve this equation manually or by the calculator, you will find the velocity will be 6.4 meter per second. Question number 51. Let me make it bigger. Question number 51. According to Bernoulli's equation, what happens to the sum of the pressure and the energy per unit volume? Let us, the pressure is very simple, so let us go to the another part, which is energy per unit volume. The energy here is the mechanical energy, the sum of the kinetic energy and the potential energy. So the energy here is the kinetic energy, which is half mv power 2 plus the potential energy, which is mgh. Let us take m as a common factor. All of this, he said in the question, per unit volume. Energy per unit volume. So we will divide the whole energy over the volume. Okay. Let us take m as a common factor. M half b square plus gh. All of this over v. We all know the mass and the density is equal to m over v. M over v. So the mass is simply equal to the density times the volume. So we can put the density or rho instead of m. So we found this, v and v cancel. V and v cancel. And we will found this, all of this, or the sum of energy per unit volume is equal to the density times half b power 2 plus gh, which means let us multiply the density by the two things. So the sum of energy per unit volume is this. He asked in the question about the pressure plus the sum of energy per unit volume. Have um, I'm sorry, we have to remove this from here. B square plus GH. According to Bernoulli's equation, the sum of all of this is constant. So it doesn't change if the diameter increase or decrease or anything. The sum of the three things here is constant. So the answer is C. Actually, if you know Bernoulli's equation, you have to answer this question without all of these steps. But I wanted to prove it to you. Question 52. Very easy question. Yes, he gave us the density, the flow rate, but he didn't also mention what it is volume flow rate or the mass flow rate. How can we know from the unit? The unit here is kilogram per second, so it is a mass flow rate. The mass flow rate is equal to the mass over the time. The mass is simply equal to the density times the volume. The density times the volume over T, which is equal to the volume. We all know the volume is equal to the area times the height. Over T, and as we mentioned in the volume flow rate, the height, which is a normal distance, over the time, it is the speed or the velocity. We can remove h over t and say v instead of this. The mass flow rate in the question is 0.25, which is equal to 0.85, which is the density times 10 power 3. We just substitute in the rule. Times the area times the volume, but we don't have the area, so we will calculate it. The area is equal to pi r square, so 3.14, which is pi, times 0.5, which is 0.01 is the radius. So we will put it here. So the answer of the area will be this number, 3.14 times 10 power -4 times 10 power negative 4. All of these is equal to I forget to write the unit. So we calculated the area. Let's put it here and continue substituting. Ten power negative 4 times the speed or the velocity. All of these, after you solve this manually or by the calculator, you will find the velocity is equal to 0.84 94, I'm sorry, meter per second. So the answer is D.